Okay, so we have a 1.6 kilogram block. It slides with a speed of 0.95 meters per second on a frictionless, notice it's frictionless, horizontal surface until it encounters a spring with a force constant of 902 newton meters. The block comes to rest after compressing the spring 4 centimeters. So they want you to find the spring potential energy, the kinetic energy of the block, and the total mechanical energy of the system for each of the following compressions. A picture for this, you would have the block coming in and you have your spring sitting here, and in the next picture your block would be just at the spring, and then finally, whoops, that spring's kind of goofy, and then finally you've got your block and it has compressed the spring. So our first compression distance here is 0. So at 0, and then you'd have one that would be 2 centimeters, and then you'd have another one that would be 4 centimeters. So it progressively gets worse as you go through. Let's do this first for 0 centimeters. We know that the total energy is equal to the kinetic plus the potential due to the spring. The energy here is all kinetic because it hasn't touched the spring yet. Because it hasn't touched the spring, we're going to say that's equal to 1/2 mv squared. And now we can plug all our numbers in, and you should end up, when you get done with all your numbers, so this would be 1/2 of 1.6, and then does it give us a speed? Yeah, so our speed here is 0.95, thank you. So 0.95, and that would give you 0.72 joules. So your energy here is all kinetic. So this would be both total, and it would be kinetic. So you could say E or K, doesn't matter, either one. For 2 centimeters, now it's going to have both. Now it should have a little bit of both. So our energy here total is 0.72 joules. We know that the potential energy of the spring should be equal to 1/2 times K times x squared. For this one, this is 1/2. Our K is 902, and our spring is 2 centimeters. We have to be careful because 902 is in newtons per meter. So because this is in newtons per meter, we need to make sure we keep that distance in meters. So this would be 0.02 meters. And if you find that, you should end up with 0.18 joules. You should end up with 0.18 joules. Now all you have to do is just take the total energy, which is 0.72, minus 0.18, and that will give you the kinetic energy of the object at that point. And you should end up with 0.54 joules for kinetic energy. The very last one, this will be for 4. This will be for 4 centimeters. And this one's really simple. We know the total energy is equal to 0.72 joules. We know the kinetic energy here is equal to 0, and you don't have to solve for the spring energy because you know that the energy total minus the 0 kinetic energy should give you 0.72 joules of spring energy now that it's compressed that 4 centimeters and it's not moving.